Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to find the empirical formula of a substance when all you're given is the elements in that substance and how those elements react with certain things to form compounds that you know the masses of. But before we get into this, please subscribe to my channel, hit the notification bell, and let's get into this. Okay, so you have a student who took an unknown sample mass of a compound that has titanium and chloride in the substance. And you put it in some water, and you're told that the titanium formed TiO2. So you have that substance is formed, and they tell you that when you dry it and you weigh it, you get a mass of 0.77 grams. So you know the mass of the titanium, the TiO2, um, and so we can use that. And then they say that you add the silver nitrate, you add that to the solution. That's my shorthand way of saying solution, until all of the chloride ions were converted to 5.575 grams of silver chloride. So you've got two compounds. So you know your unknown has titanium and chloride ion in it. Okay. And they tell you that the titanium forms 0.777 grams of the titanium fluoride, and you're told that all of the chloride ions form 5.575 grams of the silver chloride. So what does that tell us? That tells us that all of the titanium in our original substance is in the titanium fluoride, this number of grams here. And all of our chloride ions, or chloride, is found in this amount of silver chloride. So uh, the thing we got to keep in mind is they want to know what is the empirical formula. So the empirical formula, if you remember, is just the formula of the compound in its smallest, simplest whole number ratio. So that's all we need to do. To find the mole ratio, or the simplest whole number mole ratio between the two elements, you just need to find the mole amounts of those two elements and then divide the smaller into the smaller one into the larger one, so that way you get a 1 to something ratio, right? That would be the simplest ratio, it would be 1 to something, right? So all we need to do is find the mole amounts of each of these, and we can do that because they gave us the masses of the compounds that those elements formed. So all we need to do is use our roadmap, right? So we have our mass of A in grams goes to moles of A, and that we, in order to make that conversion, we use the molar mass of A, and then to go from A, moles of A, to moles of B, I'm going to use a different marker. This one's squeaking too much. Moles of B, we're going to use the mole ratio between A and B. And then to go from moles of B to mass of B, you're going to use, again, the molar mass, and then B, molar mass of B, to get mass of B in grams. Okay, so we know the masses of compounds, right? The masses of our compounds that were formed that have the elements in the compound. So all we need to do is start with the mass of the compound we have and follow our roadmap until we get to moles of the other substance we want. So we want to go from the mass of grams, the gram amount of titanium 4 oxide, and then go from that to moles of titanium. Titanium would be our B. So the titanium oxide is our A, and then we want to convert that to moles of titanium. So we're going to follow our map. So let's start with the 0.7, 0.777 grams of TiO2. We're going to put that over 1, and we're going to follow our roadmap. So we want to convert grams to moles first. So we're going to use the molar mass of our titanium oxide to convert that to moles. So we need to look that up. So you calculate that using your periodic table. And so when we calculate that, we find it to be 79,865. So 79.865 grams of TiO2. And I put the grams on the bottom because I have grams of TiO2 on top, so that'll cancel out. So now I have 1 mole of TiO2 on the top. So grams cancels out. Now I have moles of TiO2, and now the next step is to get moles of Ti, which is my B. And I need to use the mole ratio. I'm going to get that mole ratio from where? From the formula. So the formula is a 1-to-1. So for every 1 mole, or every 1 formula for this, I get 1 Ti, titanium atom. So it's a 1-to-1. So for every 1 mole of this, I get 1 mole of titanium. So I'm going to use that. So I'm going to use a 1-to-1 mole. So for every 1 mole of titanium O2, so TiO2. So I'm going to put 1 mole of TiO2 on the bottom, and then I'm going to have 1 mole of titanium on the top. So moles cancels out. I have moles of titanium, which is what I want. So I'm done here. So all I need to do is calculate this answer. I'm going to multiply by everything on the top, and then I'm going to divide by everything on the bottom. And when I do that, I get an answer of 0.465. 0.465. I have 69. So it'll be 69 moles of titanium. And then the next thing I want to figure out is make sure I know what my sig figs are for my answer. So here I started with 3 sig figs. The 0 at the beginning of the number is not significant because it's a leading 0. It's the 0 at the beginning of the number, and those are never significant. So I have 3 sig figs here, 3 sig figs here, and I have 1, 2, 3, 4, 5 sig figs here. So that means that my answer should have 3 sig figs. So 1, 2, 3. So the 5 is my last sig fig. But I keep 1 or 2 extra digits to avoid a rounding mistake. Okay, now that I have moles of titanium, all I need to do now is get moles of my chlorine. And so I'm going to now use the mass of the silver chloride, because all of the chloride that was in my substance is now in the silver chloride. So now all I need to do is do the same thing, convert the mass of my silver chloride to moles of my chlorine or chloride ion. So let's start with that. So we have 5.575 grams of my silver chloride. I'm going to put that over 1, and I'm going to multiply by I'm going to use the conversion, the molar mass of silver chloride as a conversion factor. So I need to look that up or calculate it. So I've already done that. You're going to have to do that as well. And so I have 143.32. So 143.32 grams of AgCl and 1 mole of AgCl on top. Again, I put the grams of AgCl on the bottom because I have grams on top and I want to cancel that out. So now they cancel out, grams of AgCl. Now I have moles of AgCl. So now I'm going to use the mole ratio again in my formula. That's going to help me convert to moles of the chloride ion. So again, you can see that for every one AgCl, you have one chloride ion. So that's a 1-to-1 ratio again. So we're going to use a mole ratio of 1-to-1. So since I have moles of AgCl on the bottom, I'm going to put that, on the top, I'm going to put that on the bottom. So 1 mole of AgCl on the bottom and 1 mole of Cl on the top. So moles of AgCl cancel out. Again, it's a 1-to-1 ratio because the formula AgCl is a 1-to-1 here. So for every one of these, I have one chloride ion. So now I have moles of the chloride ion. I have moles of titanium. So now all I need to do is calculate this again. I'm going to multiply by everything on the top and divide by everything on the bottom. And when you do that, you get 0.0388, 0.0388. I have a couple more digits that I calculated. 98 moles of Cl. Okay, so let me make this so my decimal points are clear. Okay, so now I have the moles of the elements in my compound, and in order to get the empirical formula, all I need to do is divide the smaller one into the larger one, so I get a 1 to something ratio, and that's going to tell me the number of atoms in my substance. Now, the thing you want to watch out for is if you divide the smaller into the larger, and you get a fractional amount. Sometimes you get a 0.5 fraction, sometimes you get a 0.25, a 0.33. If you get something that's close to an obvious or clear fraction that you're familiar with, like 0.333 would be 1/3, 0.25 would be 1/4, 0.5 is obviously 1/2. You would then have to multiply your formula, the subscripts of your formula, by the factor that's going to get rid of that. So if you have a 0.5 in there, then you're going to have to multiply everything by 2, the subscripts by 2 to get rid of that fraction. If you have a 0.3333 or something very close to that, then you're going to have to multiply by 3 to get rid of that 1/3 fraction, and so on. But let's see what we get here. So all we need to do is take this number. This is obviously smaller than this. So we're going to divide this number into this. So we're going to put 0.465 moles of titanium, and we're going to put that over 0.0388898 moles of chlorine now, or chloride ion. So now we have to make sure we have the right number of sig figs over here. So we have 4 sig figs here. We have 5 here. So our answer should have 4 sig figs. So 1, 2, 3, 4. So the last significant digit is the 9. We're keeping an extra 1 to avoid rounding error. And then we'll underline the same ones here. So this 5 is our last, and then this 9 is our last here. Now, if we divide these, what do we get? We get well, let's see what we get. All right. Oh, I found a mistake. So this is not correct. That is actually 0.00 97289. 97289 Ti. Let me double check this answer there. Okay, that seems to be correct. Okay, so we're gonna have to change this a little bit. So since this is the smaller number now, we're gonna put that on the bottom. So we have 0.009728 titanium. Oops. We want that on the bottom. So we want 0.038898 mole of chlorine, and that's going to be over 0.009728 titanium. And again, this is going to be the third digit is going to be the significant one. The fourth one is significant here. And so when we divide those, we get, that's going to be 3.998 3.998 ... And so as you can see, that is really close to 4. So might as well round to 4. So that means that the ratio of titanium to chlorine is 1 to 4. So there's our empirical formula. So the empirical formula would then be Ti. So for every 1 Ti, we get 4 chloride ions. So Cl4. That's going to be our empirical formula. So TiCl4. So I hope this was interesting. I hope you learned a lot from this. I hope this was helpful. Thank you for joining me. Please don't forget to like this video. If you like it, share it. Hit the like button, subscribe to my channel, and hit the notifications. Thanks for joining me. Have a great day.